So, dear students, now we are going to discuss the topic of signal flow graph. So, the signal flow graph represents the transfer function as lines, signals as small circular nodes. So, here these signal flow graphs are alternative to the block diagram. So, the signal flow graphs used to reduce the block diagram. So, here for that we are using the rules is Mason's rule for reducing the signal flow graph to single transfer function. So in that signal flow graph, it consists of and nodes, branches and nodes. So the next thing is we are going to discuss about what are the elements involving in the signal flow graph. The first thing we should know what is loop gain. The first thing we should know what is loop gain. So the product of branch gains traversing the path start a node and end at the same node. So this is called as loop gain. So now see here that given diagram. So how many loops are forming? So simply have to remember the loop gain is nothing but first that particular branch is start from one node and then again it repeated at same node with feedback path. So now see here the first loop gain is G to H1 of us and the second loop gain is G4 H2 of us. The next thing is G4 G5 H3 of us. The next thing is G4 G6 H3 of x. So this is the loop gain. The next thing is forward path. So how to find the forward path means you need to find how many ways are there from starting node to end node. So this is the forward path. Now see here from R of S to C of S, what are the ways or what are the paths available to destination nodes. So now here from this given diagram we have two forward paths. So what are they means? See here first the straight forward path G1, G1, G2, G3, G4, G5, G7. And the next thing is so only you need to do the forward direction, not reverse direction because the reverse direction is feedback path. So now only you have to concentrate on forward path. So there you see here G1, G2, G3, G4, G6, G7. The next thing is non-touching loop. That means that loops that do not have any nodes in common. So if you want to compare the loop gain, the two gains, so that is if it is having two common nodes means that is two non-touching loops. Similarly, uh, non-touching loop means that loops that do not have any nodes in the common. So here that in our diagram also we have G2H1 of us and G4H2 of us are non-touching loops. Similarly, G5H3 and G4 G6H3 also non-touching loops. So the next very important thing is we should know what is Mason rule. So the Mason rule formula is the transfer function is equal to 1 by del summation of k into del pk into del k. First we should know what is del. So del the formula is 1 minus sum of all individual loop gain and plus sum of gain product of all possible two non-touching loops and minus sum of gain product of all possible three non-touching loops. And the next thing is you should know what is the forward path. Okay. So based on the forward path only, you can calculate the summation of pk into del k. So in our given example, we have two forward paths. So that means how to write del p1 del 1 plus p2 del 2. So here how to calculate the del k value means you need to find the part of the graph which is non-touching k, the forward path. So now the properties of signal flow graph. See here if you are having the incoming signal given by the product of signal is previous node, you need to write A1 x1 and A2 x2. Similarly, the cascade branches you can split up. Similarly, the parallel branch you can represent as a straight line. Similarly, the mixed node also you can represent it as the same thing. The first thing, steps to construct the signal flow graph. Here, the four main procedures are there. The first thing, arrange the input to output nodes from left to right, and connect the nodes by appropriate branches. And if the desired output has outgoing branches, add a dummy node and unity gain branch. The fourth thing is rearrange the node and the loops in the graph to achieve pictorial clarity. Thank you.